All right. All right, let's get going with where we left off on Wednesday. And before we get into this, because we are going to be doing some more composition of functions. So I'm just going to rework or do another example of what we did at the very end of class on Wednesday. It would have given us two functions, usually an f of x equals x plus 5 and a g of x equals something like x squared minus 1. And then it would say find f of g of negative 5. So the first thing we always did was find the inside of this composition, which means g of negative 5, which means go to your g function and replace that x with negative 5. So if I do that, I will have negative 5 squared, right? If I put my negative 5 in place of the x, so negative 5 squared minus 1. Negative 5 squared gives me 25. Bring down the minus 1 to get 24. So there was the first part of the problem. The second part of the problem says now you're going to find f of whatever that solution was. So I'm finding f of 24, which means now I'm going to go to my f function and replace its x with a 24. So if I do that, I'll have 24 plus 5, which gives me 29. So that's how we did the composition of functions. Found the inside of the composition first. So went to the g, replaced its x with negative 5, got a solution, then used that solution to go find the outer part of the composition. Now, on Wednesday in 9.1, we did 1, 2, and 3 that were all like this. Now moving on to number 4. All right, it's still going to give me two functions. My first function is f of x equals x plus 25. G of x equals x minus 25. Now, it's going to want me to find two things. It's going to want me to find f of g of x and g of f of x. So I'm going to find the composition both ways. It's also going to ask me to find the domain of each of those. So let's see. The first thing it wants me to find is f of g of x. So I'm finding the inside of the function first, g of x. Well, the problem simply states exactly what g of x is. If I look up here, this says g of x equals x minus 25. So g of x equals x minus 25. Now, I'm going to, at this point, start looking for restrictions in the domain because it's going to ask me in a minute, what is the domain of the final answer? And there's two places that you're going to look for restrictions in. What you plug in, which is x minus 25. So I'm going to put over here a little side note for the domain. So remember where we had restrictions. Restrictions came into place if we had a fraction that had an x in its denominator. Let's look at this. Do I even have a fraction? No. So far there are no restrictions. So now the second part, when I'm finding the composition, once I found the inside part, got a solution, what did I do with that solution? I went and plugged it into the outside part, which is the F part in this case. So instead of it just being a plain number here, I'm finding F of x minus 25, which means now I am going to go to my F function, which is right here, and wherever I see an x, I'm going to put in x minus 25. So let's see, there's my x right off the bat. So instead of writing x, I write x minus 25, then bring down the plus 25. What happens when I combine the negative 25 and the positive 25? They just cancel each other out, which means I am just left with x. So that's the composition of the functions. So now, let's look at the domain of this. Is there any restrictions in the function just being an x? No, because there's still no denominator. So there is no restrictions in either part. So again, you're looking, when you're talking about the domain of these compositions, you stop here and say, are there any restrictions there? Since there's not an x in your denominator, there's not a restriction in that part of the domain. So make note of that. Then finish solving the problem, which means use this, x minus 25, and plug it in for x. And then clean it up. So here's your final answer. That x is your answer. But then it's going to, and then you say, okay, are there any restrictions here? Since there's not, again, no restrictions, no restrictions. Because the second part of this problem is going to want you to find the domain of this. Since there's not any restrictions, there's nothing that x cannot be. It wants you to write, that means in the last section, we just call that x is a real number. Because it could be anything. This section, it wants you to write this in what's called interval notation, which uses infinities, negative infinity to positive infinity, but leave out any restrictions. Well, since there's not any, your domain is simply negative infinity to positive infinity. So that's the domain of f of g of x. These may take some work. So let's look at the second part of this problem. We found f of g of x was x, and its domain was negative infinity to positive infinity. Let's find it the other way around now. Now, instead of f of g, it's going to want us to find g of f. G of f of x. So find the inside first. Remember, you're always finding the inside of the composition first. So I'm finding f of x. Well, the problem as it's written tells me exactly what f of x is. F of x is x plus 25. So I'm done with that part. So remember, at this point in finding the composition, you kind of stop yourself and say, okay, are there any restrictions yet? Which means, is there a denominator with an x in it right here? No. So right now, as of right now, there are still no restrictions. Then keep going with the composition. I found the inside, f of x. I got a solution, I just couldn't simplify it. So now I find g of that solution, which is x plus 25. Which means go to my g function, wherever I see an x, which is right here, what am I going to put in its spot? x plus 25. So let's see, right off the bat, there's my x, so I'm going to replace it with x plus 25. What comes after x? Minus 25. So once again, what happens to the plus 25 minus 25? They cancel, and you're just left with x. So there's the answer to the composition. Now you're trying to say, is there any restrictions in this part? Well, it's just an x. I can put anything there I want. There's no restrictions in that part of the domain either. Which means no restrictions in the first part, no restrictions in the second part. So there's no restrictions at all. So your domain, again, is negative infinity to positive infinity. All right, the last part of this. Number 6. Same thing, except my functions are a little bit more complicated. My first function, my f of x, is 5 over 1 minus 4x. My g of x equals 1 over x. I'm going to do the same thing. I'm going to find f of g of x, g of f of x, and the domains of each of those. So let's see, what's first? F of g of x. So let's see, what's my inner? G of x. What is g of x? Again, it tells me right here what g of x is. G of x is 1 over x. So I'm done with the inside. Now remember, at this point, you pause yourself and say, okay, in a minute, I'm going to have to find the domain of my solution, which means I need to look at this part right now and see if there's any restrictions. This time there is, right? Because this one does have an x in your denominator. So I know that x, whatever my denominator is, can't equal 0. So there's a restriction. So here's your kind of your domain side note. That right now I need to remember that my denominator can't equal 0. Since it's just an x, I know x can't equal 0. Now I'm going to keep going with the composition. I've just done the first part. So now I need to find the outer. So I'm finding f of, what was your solution in the first part? 1 over x. Here's where it gets messy. Because now what am I doing? I'm going to my f function. Wherever I see an x, which is right here, what am I going to put in place of this x? I'm going to put a 1 over x. So let's just rewrite the f function, replacing the x with the 1 over x. So it's going to look like this. 5 over 1 minus 4. Instead of x, I put 1 over x. Now, math etiquette states that you cannot leave your answer with a fraction within a fraction, right? This looks horrible. I need to clean this up. Now, remember, I can multiply anything I want times 1, the number 1, right? And not change its amount, right? 10 million times 1 is still 10 million. So what I'm going to do is I'm going to multiply this whole fraction by a fancy 1, okay? The 1 is going to be whatever this denominator is of this bottom fraction. I'm going to use it and multiply that times the top and the bottom. Because, look at that. That's just a fancy 1, right? Anything over itself is 1. Here's the reason I'm doing that. The top is not bad. What's 5 times x? Well, it's just 5x. Here's why I use this x. This x goes to both terms of that denominator. Well, the first thing I have is x times 1. Well, x times 1 is just x. But look what happens here. If I multiply x times all of this, what's really happening is this x cancels that one. And I'm really just left with 4 times 1. So that's why you use the x. X over x cancels. 4 times 1, so minus 4. So there's the answer to your composition. 5x over x minus 4. Now, remember, I am going to have to find the domain of this. I already found one restriction in it. Is there a restriction here? Yeah. I have another x in my denominator that I need to worry about. Let's see. X minus 4 can't equal 0. Solve it. So add the 4 to both sides. So x can't equal 0 plus 4 is 4. So there's the other restriction. So there's 2 restrictions that I need to show. X can't equal 0 and x can't equal 4. So how am I going to show that in interval notation? So I need to take into account all the numbers below 0. So let's see, that would be negative infinity to 0. So that took care of all the numbers below 0. Remember, the numbers between 0 and 4 are okay also. I just can't have 0 and I can't have 4, but I need to include the numbers in between them. So this little u stands for and this part of your problem is going to be multiple choice, so that'll be there for you. So now I want to include all the numbers between 0 and 4. So those are fine. Now, so I've included all the numbers below 0, all the numbers between 0 and 4. What's the last group of numbers that I need to include? All the numbers, so and all the numbers from 4 to infinity. And again, that part will be multiple choice for you. So there's the first part of that question. So what have I done here? I have found f of g of x, worked it all the way out. It gave me 5x over x minus 4, so that's the answer to that part. And then after that, it's going to say, well, what's the domain of that? And remember, you had to look for restrictions in 2 spots. Here, that's what gave me the 0 restriction. And here, that's what gave me the 4 restriction. And that's your domain and interval notation. So now I'm going to do all this again, but instead of f of g of x, I'm going to find g of f of x. Okay, so all the same thing for g of f of x. So find your inside. What is f of x equal to? The only thing easy about this problem is I know what f of x is equal to. It tells me right here in the beginning of my problem. F of x is equal to 5 over 1 minus 4x. So that's what f of x equals. 5 over 1 minus 4x. Now remember, at this point, you pause, find in the composition and say, does this first part give me any restrictions? In other words, is there an x in the denominator? Yes. So let's keep track of our domain restrictions there. 1 minus 4x can't equal 0. Solve it for this x. So subtract the 1. So negative 4x can't equal 0 minus 1 is negative 1. And divide by negative 4. Divide by negative 4. So x cannot equal, that negative over negative makes it positive 1/4. So there's my first restriction on the domain. X can't equal 1/4. Now, come back to your composition. I found the inside. F of x equals 5 over 1 minus 4x. Now I need to find the outside, which is g of whatever that solution was. What was the solution to the first part? Well, this mess right here, right? I just can't simplify it. 5 over 1 minus 4x is what I'm finding g of. So go to your g function. Wherever you see this x, you're going to put all of that, which is going to create a very complicated fraction that we're going to have to clean up. So let's see, I've got 1 over, what do I put instead of the x? All of this. 5 over 1 minus 4x. Now, just like the first part of this problem, I have a fraction in my denominator, which I can't have. So that's what I'm going to have to clean up. Here's it. Remember how we cleaned up the last time? We looked at the denominator of that fraction, which was just an x, and that's what we multiplied the top and the bottom by. So what's the denominator of this fraction? We're going to use the same method. The denominator of this fraction is 1 minus 4x. So that's what you're going to multiply the top and the bottom by. So let's see what that gives me. Up top, 1 times anything is just itself, right? So this 1 times 1 minus 4x just gives me 1 minus 4x. Look what happens in the bottom, though. This is what's nice. This is why you do it. 1 minus 4x cancels out 1 minus 4x. So what's the only thing left in this denominator? Just a 5. So you're actually done with the composition. There's the answer to g of f of x. But remember, and then the next part is going to ask you what the domain is. So I already found my first restriction from here. Now I'm looking for any other restrictions. Look at your answer here. In order to have a restriction, you would have to have an x in this denominator. Right? There is a denominator, but there's not an x in it. So there is no restrictions in this part. So the only restrictions to the whole composition is 1/4. So if I'm going to write that in interval notation, I would say negative infinity all the way to 1/4 in union with, or and, 1/4 to infinity. So that's what that says in interval notation. Everything from negative infinity to positive infinity, leaving out 1/4. All right, so that is the end of 9.1. 9.2 is not near as bad as this. Is talking about the inverse of functions. The inverse of functions simply means to invert x and y on certain functions. So on number 1, It's just going to give you a group of points. And each point has an x coordinate and a y coordinate. So the first point is -5, -9, 5. Second point is -7, -1. Third point is -5, -3. And the last point is 5, -5. Now remember, all points have an x coordinate and a y coordinate. So if I'm finding the inverse of these 4 points, I'm just simply rewriting them, flipping the x and the y. Okay, so let's look at what that would look like. Go again, just switch the x and the y. So this will be 5, -9, comma, because it's going to ask you to put a comma in between those ordered pairs. Switch the x and the y here. So -1, -7, comma. Switch the x and the y. So -3, -5, comma. Switch the x and the y. -5, 5. That's all you do on number 1. Actually, I can do number 2 right down here. Find an equation of the inverse relation. So you have x cubed y equals -5. So what did I do on all these points? I just switched the x and the y. That's all you're going to do to this to find its inverse equation. So again, switch. So I'll just have y cubed x equals -5. And that is it. So on those first 2, don't make them any harder than they are. Just switch in x and y's. Now, 3, 4, 5, and 6 are going to use what is called the horizontal line test to determine whether functions are one-to-one or not, because only one-to-one functions have inverses. So remember what the vertical line test told us. All right, the vertical line test, remember that we did in last week, told us that if you can draw a vertical line anywhere on the graph and only touch the picture once, not counting my x and y axis. So here's the graph, that straight line, or that horizontal line. If I draw a vertical line, look, I only touched it once. So yes, that is a function. What about this one? No matter where I draw a vertical line, it's only going to touch that shape one time, right? It doesn't matter where I put that vertical line. It's only going to touch it once. What about this last one, though? How much did that vertical line touch it? Twice. So this was a function, but this was not. Now we need to determine if these are one-to-one. So that one I don't even use because it's not a function. I'm going to draw my line. So yes, this one was a function because it only touched it once. Now let's see if it's also what's called one-to-one, which means does it pass the horizontal line test? The horizontal line test is used to determine if the function is one-to-one or not. Okay? So forget about the vertical line test. Okay, we don't even use this one because it's not even a function. So looking at these are both functions. They both pass the vertical line test. Let's see if they pass the horizontal. Look at this horizontal line. How many times did it touch the graph? Once. So yes, that is one-to-one. But look at this one. It is a function because it does pass the vertical line test, but doesn't pass the horizontal line test. Touches there, touches there. So no, it's not one-to-one. So we're going to use that knowledge to work 3, 4, 5, and 6. Which is simply just seeing if these graphs pass the horizontal line test. Number 3 looks like this. My x-axis, my y-axis, then the graph of it looks like this. Does this pass the horizontal line test? Anywhere I draw a horizontal line, how much does it touch? There's just once, 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 once. It never touches more than once, which means yes, this is a one-to-one function. Number 4, x-axis, y-axis. The shape of the graph looks like an upside down parabola. Does that pass the horizontal line test? If I draw a horizontal line right here, how much does it touch that upside down parabola? Twice, which means no, this is not a one-to-one function. Number 5. X-axis, y-axis. Graph looks like this. Horizontal line test. I draw a horizontal line right here, I touch it there and there. So it already does not pass, right? If I drew a horizontal line down here and touch it more than once again. So it doesn't pass it in several different spots. So no, this one is not one-to-one. And the last one like this, number 6. X-axis, y-axis. Something like that is what the graph looks like. Does this pass horizontal line? Horizontal line, horizontal line, horizontal line. Yes, it does pass. It never touches the graph more than once. So that's all you're doing on 3, 4, 5, and 6 is simply using the horizontal line test to determine whether the function is one-to-one or not. All right, now 7 through the end gives us functions and says find the inverse of them. So let's think about what that means. What did we do on numbers 1 and 2 to start finding the inverse? We simply switched the x and the y. So we're going to do the same thing here and take it a step further and find the complete inverse. So the steps to do this, the first step, a lot of times you're going to see the function given to you with an f of x instead of a y. But remember, they mean the same thing, right? So the first thing you're going to do if you see f of x is replace the f of x with a y. Now, the second part of it is when we do the flipping. So you're going to interchange x and y. So just flip them. Now, the last step after you flip the x and the y is to solve for the new y, wherever the new y is located. So you're going to follow those steps for 7 through 12. So let's look at number 7. 7 says f of x equals x plus 8. Now the first thing it's going to do is ask me, is this function 1 to 1? Or in other words, does it pass the horizontal line test? So if you went and put this in your y equals and put in x plus 8, it's going to give you a line that looks like that. It's going to pass the horizontal line test. It is a 1-to-1 function. Okay? So then it's going to ask you, since this is a 1-to-1 function, find the inverse. That's where you follow these 3 steps. So my first step is, if I have an f of x, don't write it as f of x, write it as y. So y equals x plus 8. Then interchange your x and your y. So flip them. So x equals y plus 8. After you interchange the x and the y, then what do? You solve for where the new y is. So here's my new y. So I just need to get rid of that plus 8 with a minus 8. So there's my y by itself. Y equals, over here I've got x minus 8. Those are not like terms, I can't put them together. So that is simply what it is, x minus 8. So there's your inverse, x minus 8. Now instead of saying y, and it'll give you this part, the inverse, when you look at it, it says f to the negative 1 of x. That means this is the inverse of f of x. So, but it's going to have this part there for you. All you're going to have to do is type in that x minus 8, what you got for your answer. Number 8. F of x equals 4x minus 6. Again, it is 1-to-1 because if you put that in your y equals and graph it, again, it's just a line. So let's go through the steps of finding the inverse. Replace f of x with y. So y equals 4x minus 6, right? These two terms are interchangeable. F of x and y always mean the same thing. So after I replace the f of x with the y, then I'm going to interchange the x and the y. So now I have x equals 4y minus 6. And what was the last step after you interchanged? You solve for your new y, which means I need to add 6, Cancel out the minus 6. I still have 4y over here. Over here, I've got x plus 6. What's the last step to get this y by itself? Divide by 4. Divide by 4. So your 4's cancel. There's your y. That's your answer. You can just write that whole fraction in. X plus 6 over 4. All right, number 9. F of x equals 3 over x plus 9. All right, replace f of x with y. So y equals 3 over x plus 9. Now, what was step 2? Interchange x and y, so I need to flip them. So now I have x here equals 3 over y plus 9. Now, here's the thing on this. Now, what are you solving for? Unfortunately, you're solving for this y right here. So if what you're solving for is in the denominator of a fraction, the first thing I would do to solve this for y is multiply both sides, and you'll see why in a second, over this whole denominator. So y plus 9. Because remember, I can do anything I want to an equation as long as I do it to both sides. Look what it does to the right. The y plus 9's cancel each other. I'm just left with 3. Here, what am I doing here? This whole thing times y plus 9 is times this x. So that x goes to both of those. So now I have x times y, which is xy, plus x times 9, which is 9x. So I'm getting there. I'm still a few steps away from getting that y by itself, but at least now the y is not in the denominator of a fraction. Now I can isolate this y, get the y by itself. I need to subtract the 9x. So now what do you have? On the left, getting closer, I just have xy equals, on the right, I've got 3 minus 9x. So now getting y by itself, the only thing that needs to go away now is that x. So since it's hooked on, I'll divide everybody by x to see what I get. So on the left, I just have y. So now, once I simplify that right side, I'll be done, right? Because y is by itself equals. Can you simplify 3 over x in any way? No. Minus. Look at this. You have 9x over x. Those x's will cancel. So you'll just be left with minus 9. All right, number 10. F of x equals x cubed minus 5. Replace f of x with y. So y equals x cubed minus 5. So now interchange x and y. So x equals y cubed minus 5. Solving for y. So I got a cube here I'm going to have to mess with in a minute, but I can get rid of that minus 5 by adding 5. So let's do that first. So let's see, I've got y to the third left. Over here I've got x plus 5. So now let's think about this. The only thing I need to get rid of is that cubed exponent. So how do you get rid of stuff? How did I get rid of minus 5? Well, I got rid of it with plus 5 because they're opposites of each other. They cancel each other out. So to get rid of this cubed exponent, I need to figure out what's the opposite of cubing the y. The opposite of cubing is taking what's called the cube root. The third root. The cube root is going to cancel out the third power. So you'll just be left with y. But if I took the cube root of this side, don't I have to do the same exact thing to the other side? So now the cube root of x plus 5 is what is left over here. And that is your answer. You leave it. There's nothing else you can do with that. All right, 2 more. I know I'm going to run over a couple of minutes, but we need to get through this. 2 more. Now, this one has something a little funny in the instructions, and let's look at why. It says, given the function f of x equals 3x squared plus 2. Then it says where x is greater than or equal to 0. And here's why it says that. It says that because if I put this in my y equals, which I actually think I have it already in my y equals. Yeah, so 3x squared plus 2, and I graph that. Look, it's not 1 to 1. The whole graph is not 1 to 1, right? Because it doesn't pass the horizontal line test. But, so this is the shape of it. So again, it doesn't pass the horizontal line test. But here's my x-axis. Here's where x is 0 on the graph, right there. It says only take into consideration where x is greater than 0. Well, x is greater than 0 on this part of the graph, but not this part of the graph. So it says don't even take into consideration that part of the graph. Now does that pass the horizontal line test? Now it does, because it doesn't matter where I draw my horizontal, it's not going to touch it twice. Okay, so let's find the inverse. So replace the f of x with the y. So y equals 3x squared plus 2. Interchange x and y. So x equals 3y squared plus 2. Solve for y. So get rid of the plus 2 first. So minus 2. So plus 2 minus 2 cancels. I'm left with 3y squared. Over here, I have x minus 2. Still going to solve for y. I need to get rid of the 3 now, so I'll divide by 3. So I've gotten rid of the 3. So now I only have y squared over there. On this side, I have x minus 2 over 3. Now, remember how we canceled out the cubed with the cube root? Now I'm just going to cancel a square out with a square root to cancel it. Square root there, square root that whole side. So now, on my right side, I just have the y. And what do you have over here? All this that you just can't simplify. You've got the square root of x minus 2 over 3. And it doesn't even make you type that whole thing in on that problem on number 11. If you'll notice, it's already got the square root in and the 3 in the denominator. So all you have to do, there'll be a blue box up in the top, and you'll just put the x minus 2 up there. All right, last one. And then there's one little thing I want to share in Math Lab real quick, just so you don't have a headache with it later. F of x equals the square root of x plus 6. So replace the f of x with the y. Y equals the square root of x plus 6. Interchange x and y. So x equals the square root of y plus 6. So again, I just switched the x and the y. Now I got to solve for y. But look, it's like it's trapped underneath that square root. I can't even subtract 6 yet because the 6 is also underneath that square root. So the first thing I need to do is remove the square root so I can work with what's underneath it. So if I remove it, remember, what's the opposite of square root? Here I did it backwards, but what square root and squared are opposites of each other. So if I need to knock out a square root, I'll square it. I'll square that side. I got to square this side. So on the right, the square root and the squared cancel each other out. I have y plus 6. On the left, I have x squared. Solving for y, get y by itself, which just means I need to subtract the 6 from both sides. So now, the plus 6 minus 6 cancels, so there's your y. Over here, I have x squared minus 6. Okay, now before I stop the recording, I do want to show you one thing. Let me share my screen. In your homework, which will be in student links, my math lab, all assignments. On number 9.2, remember how number 10 had a cube root in its answer. So the first thing it's going to ask you if it's 1-to-1. So you would check yes, it's 1-to-1. Then select the correct choice. So see what I have put right here? Down here, when you click in this, there's 2 different boxes down here. One represents the square root. This other one, with the little blue box in the both spots, that represents any other radical that you're going to want to type in that's not a square root. See how it has that little, it puts that little blue box right there? So that's where you'd put, let me get up there. That's where you would put the cube root in that little box right there. And then whatever the rest of the answer is. How do you get out of there? So the cube root, and then put whatever the rest of that answer was in there. Okay? All right, remember, no class on Monday since it's Labor Day. So I will see y'all on Wednesday.